Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we will solve a problem on hydraulic machine subjected to cavitation. In our last lecture, we have discussed the theory part of this hydraulic machine subjected to cavitation, and we have discussed the theory part like how the cavitation affected on the turbine and pump. So based on that theory, we'll solve this problem. So here I have taken the question: a Francis turbine has been manufactured to develop a 15,000 horsepower at the head of 81 meter, and the speed is given 375 rpm. Mean atmospheric pressure is at the site is given 1.03 kg per centimeter square. Vapor pressure is given 0.03 kg per centimeter square. Calculate the maximum permissible height of the runner above the tail water level to ensure the cavitation free operation. We require the cavitation free operation actually, and how much height is required to keep the turbine. So the critical cavitation factor for the Francis turbine is given sigma c equal to 317 into 10 to the minus 8 into ns square, where ns is the specific speed of the turbine in M.K.S unit. So very simple, we need to find out what is the height of the turbine should be there above the tail race so that there will be no cavitation. That is our goal. So in the last class already we have discussed how to identify. So let me first write down the data given from the question here. So easily we can find out the data here. In the first line itself, the horsepower is given. So that means power to be developed. So power to be developed, that is given. This is 15,000. Okay. And the next one is given at the head of 81 meter. So the total head is given 81 meter. Next, the speed. Speed is given. That is one we can write, we can mark it as n. Okay. How much rpm? That is 375 rpm. Okay, and next is the mean atmospheric pressure is given at the site is 1.03 kg per centimeter square. So that means P atmospheric PA is given. So PA is how much? 1.03 kgf for centimeter square. This one we can convert into Newton per meter square. So how to convert it? 1.03 into 10 to the power, sorry, into 9.81. So kgf I have converted into Newton, and centimeter square we can convert into meter square, that is 10 to the power 4 by multiplying this one. So this one we can write Newton per meter square, not meter 4. Yeah. And the next one is vapor pressure is given. Same way we can write this is PV. PV equal to, I can write this is 0.03 kgf per centimeter square. So this also I can write in the same way, 0.03 into this is 9.81 into 10 to the power 4. This is Newton per meter square. So these are the data given in the question. Along with this, one more data is given, that is critical cavitation factor, that is sigma c. So sigma c equal to, we can write this is 317 into 10 to the power minus 8 into ns square. This is the value, critical cavitation factor. Okay. So what we need to find out? We need to find out the maximum permissible height of the runner. That means where we need to keep the runner above the tail water level. Okay. That means we need to find out the suction head. Okay. In the turbine, if you see, we have the runner. Okay. We have the runner is there. So where we need to keep the runner above the tail race? How much height is there? How much head is required in that? So that is nothing but HS, suction head, how much? Okay. That is our HS. So where now we'll go for the calculation. Just I'll tell you in the reverse way how we can calculate this value. Okay, so we have seen in our last lecture the formula what I told you. The formula is very simple, that is sigma c equal to HA minus, that is atmospheric pressure head, this is head, then minus HV minus HS divided by H. Now if you see in this is our formula actually. In this formula, what are the values are given? This only head value is given. We need to find out this value, and these two value we can identify from the pressure value. Okay. So now, and sigma c also, along with this also ns is given. So we need to calculate that. So what I'll do, I'll try to calculate one by one. Okay. So HA. So HA is what? Atmospheric pressure head of water. Okay. So how we can calculate this HA? It's very simple. HA equal to, I can write HA equal to, the formula is PA by rho g. PA by rho g. What is PA? PA value, that is nothing but our atmospheric pressure. How much is there? 1.03 into, this is 9.81 into 10 to the power 4 and divided by rho equal to how much? Density of water, that is 1000, and g is the 9.81. So now you can see this can be cancelled, this 30 will be cancelled, only 10. So that is 1.03, it's this one. So that means 10.3. This is our HA value. Okay. Now similar manner, I can easily calculate the HB value also. So HB value is nothing but same thing. We can write the vapor pressure head in meter of water. So the same thing, I can just write HB equal to, this is PV by rho g. So PV by rho g, in the sense I can write, already I got the value of PV, that is 0.03. This is 9.81 into 10 to the power 4 divided by rho g. Rho g again the same thing, like 1000 into 9.81. So here also I'll get the same thing, like 0.3 meter. Here also I did what I did, 1.03 into 10, here 0.03 into 10, that is 0.3. This is meter. So these two value we have identified, which was from the pressure value we have identified. Now we need to calculate sigma c. Sigma c, along with that ns is there. So how to calculate the ns, specific speed? ns is nothing but specific speed. So a specific speed of the turbine, we have the formula actually, that is speed into root over of power by head to the power 5 by 4. So this one already we have derived previously, okay, during the turbine. So now what I'll do, I'll just put the value of all these things, like 375 into root over of, this is 15,000, and divided by h head to the power, this is 5 by 4. So you can find out the value of specific speed. So now we need to take the help of calculator. This is 375 and multiply. Okay, what I'll do, first I'll go for 15,000 root over multiply 375 divided by bracket start 81 to the power, again I'll do the bracket 5 divided by 4 bracket close, again one more bracket equal to, no, this is 81 to the power 5 by 4, and here already is there. So yeah, no, this is not the value actually, divided by 291 came. No, this is not the answer actually. So okay, let me do one by one otherwise. So what will do, 15,000 root over how much, and multiply 375. So 45,000, this is 45, this is 45,927 something is there. Now in the denominator we have, how much is there? So that one we can write 81 to the power bracket start 5 divided by 4 bracket close. So this is 243. Yeah. So now this is 243. So we'll do one thing. This is 45,927 divided by 243. Yeah, 189. So we got, this is 189 rpm. This is specific speed. So now we'll put this value in the sigma c. So we can write sigma c equal to, I'll just write directly, this much square into 317 and divided by 10 to the power 8, 1 2 3 4 5 6 7 8, 0.13113. So this is 0.113. This is the value of sigma c. Just I kept the value here and got this value. Now finally this is our formula is there to find out the HS value. So put all this value in the sigma c. So sigma c equal to, yeah, let me write directly, sigma c equal to 0.113 equal to HA equal to how much? That is 10.3. We have just now we have calculated this, and minus this 0.3 minus HS divided by H equal to how much? That is 81, which is given in our question. Okay. So what I'll do here, I need to find out this value. So 0.113 into 81 equal to, this is 10 minus HS. Now what I'll do, I'll keep HS one side, HS this side, and this value 10 minus 0.113 into 81. So I can find out the value of HS here. HS equal to is nothing but this one. What I'll do, this is into this one into 81 minus 10, 0.827, 0.827, or we can write HS equal to, this is nothing but 0.83 meter. Okay, so this is our answer. Now see what they told to calculate, it's just the same thing we have calculated. So the maximum permissible height of the runner, okay, will be 0.83 above the tail water level raise. So I hope you understand how to calculate this or how to solve the problem. So the few things is we need to remember, like this is the formula of sigma c, okay, and how to calculate the head from the pressure value with respect to this. So these two formula we need to remember, and along with that one more is the specific speed, okay, specific speed of the turbine. Remaining things are very simple, we can easily solve it. I hope you understand. Still, if you are having any doubt and query regarding this, you can give a comment on the comment box. Thank you all.